Hello, it's been a little while. I hope you have been well. I know I've been. I've been kind of busy with work, but yeah, we're back with a kind of a different setup. We're running Linux here. I've been running it full time for a couple months now because I'm making the jump from Mac OS to Linux full time. So the setup's a bit experimental. So I did a test recording yesterday. I was running Sway, the Sway window manager. And I had a lot of issues. It was really slow because it didn't use hardware acceleration for the encoding. But this works nicer for now. I'm running i3 here, and yeah, I've been playing around with it for a couple of hours, and it seems to work pretty well. So tonight's hacking session is should be fairly quick. I don't know how long it'll take. I had an idea a couple of days ago that I wanted to do, which was to add support for multiple cameras. So we're gonna try and do that today. And yeah, I guess that's about it. I looked at the last video. It was like 8 months ago. I think it was in March, late March. And since then, I've been working on it on off. I've been working on C-Ray on off. I just haven't had the energy to start, record videos and put them up. So, but yeah, we're back. So let's see. I'll explain to you what I mean in a second here. What I'm going to implement. First, I want to show off a bit. Since the last video, I got the network clustered rendering working fairly reliably, so I can demonstrate that real quick here. I even made a little wiki page here. You can see cluster rendering. It just shows you how to use the different options here and some security stuff, because it's written in C, so it's probably buggy. But I can show you how it works. So I have the latest build here. And you can now use a bunch of flags related to network rendering. So you can do -- worker to start a node in worker mode, which basically just opens up a socket and then waits for connections. And that can be run like a daemon, so you can actually run it all the time. And other machines can then connect to it and use that to render stuff. And then once it's done, it listens for connections again. So let's just run a quick render here. I'm gonna run this with 25 samples. Just a little test render here. There you go. And I'm looking to the right to see if everything's going okay with the OBS. But yeah, there we go. 4.63 seconds. Let's do 100 seconds, so it takes a little while at least. Yeah, I'm pegging the CPUs here 100%, so I'm looking at the FPS here. It looks pretty good, 60 FPS. I'm actually using my GPU here for video encoding. So there we go. We'll do a little benchmark render here. There we go, 18.43 seconds. So now this rendering engine scales really well across multiple threads. So this computer has an Intel CPU with 8 cores. I think it's actually only a quad core because it's an Intel, and then it has hyper-threading. And then I'm kind of greedy. I also add 2 more threads than we actually have. Cores that the operating system reports. But we can now establish a connection to my web server here. Let me make this a bit bigger. So the default port for C-Ray right now is 2222. And then I'm going to forward this port from my web server to my local machine here. The server is called Triton. And I already built it here. I tested that this works. Here I also have the latest build here, and I can now, as you can see here, I can run this -- worker option. And also I'm gonna run -v for verbose mode, so it prints out a little bit more stuff for debugging, so you can kind of see what it's doing internally. And there you go, now it's listening. And this port should now be open on our local machine here, so we can actually add in -- nodes. And then you can add a comma-separated list of nodes and ports. In this case, we'll assume the port is 2222, so 127.1. And it should connect and do the render here. Let's see. So it connects, it uploads all the assets to the render node. And it prepares, and there you go. You can see it rendering here. The tiles that don't update live with the progress bar are the local nodes. And then the network rendered nodes are these black ones that just appear when they're finished. I think it would take a bit too much bandwidth to actually live update that stuff. And we have a double free, that's fun. Maybe we'll look into that. But this one took 14 seconds, and the previous one took 18 seconds. The effect is more magnified on longer renders. Obviously, this web server is a really old one. It's from like 2009 or 2010, so it's not that fast anyway. But I've been having a lot of fun just hooking up all the machines I have here in my room, like my personal laptop, my work laptop, and have them all kind of running full tilt here, rendering images. It's been useful, and it kind of works already. There's still evidently some bugs. What happened there? C-Ray hides the cursor when it starts, and then it tries to restore it when it stops, but obviously when it crashed, it didn't do that. I'm just gonna run this so I get the cursor back. This is a release build, so I don't think we have debug symbols enabled, but we'll see what happened anyway. Something in the teardown code. I'll fix that later. So, let me show you what I want to do today here. Okay, disconnect that, or this. So, I'll show you a simple scene here. So the way scenes work in C-Ray is that you have a JSON file, and then that references assets, and then the assets can reference assets as well. But this is kind of what it looks like. We got the settings here for the renderer, some display settings, camera, and then the scene description, which has like a couple of settings for the scene, and then you can have multiple primitives like spheres and stuff. I only have spheres at the moment. You could do all sorts of shapes that you can describe with math, and then you can load up mesh files, in this case from waveform files. But what I want to work on today is adding support for more than one camera. So I thought it would be cool so you can like send multiple cameras in a scene, because there's a script that I have that you can like bundle up your scene and all the assets into like a zip file and send it to a friend or something. But right now, if you want to have multiple cameras, you either have to manually edit the JSON, which is not ideal, or you have to have multiple different JSON files and then switch between those. So we'll try and add, so we'll just make this camera object into like a cameras. I don't know if we'll rename it, but we'll make this an array instead of an object, and then do it that way so we can actually have multiple cameras. And then I'm thinking we'll have like a flag, like -C, and then the camera index. So 0 would be the default, and then you can do like -C1 to switch to the second camera and so on. So let's try and do that. Still getting used to this environment here. And also getting used to CLAN. I started using CLAN when I moved to Linux, because I normally use Xcode. But I've been really liking it. It was slow yesterday on the test recording, because my CPU was like doing 50% all the time encoding the video. So yeah, let's try and do this. So first we'll add the argument. Argument parsing. I have this very, how should I say it? It's a very purpose-built argument parser that's just like built for this. I don't see a need to make it a generic argument parser with just this, because I'm not going to reuse this. And we'll do like this. I'm also not used to the key bindings in CLAN yet, so I'm doing a lot of manual editing. Camera. We'll select camera defaults to 0. Something like that. Now, let's see. I'll rebuild here. There we go. So now we have that. And then we actually parse it. I put it after O. Yeah, this is much faster than yesterday. Let's see. We have -J that we could borrow. It's similar. Put this here, and then I have the IdeaVim plugin that I've been kind of experimenting with. So like 153, and then we'll do O. Let's do that, and then it checks if that one, then we clamp it. If it's less than 0, we clamp it to 0. I think that's fine for now. We don't need this one. And then I'm still getting used to Vim motions here. I've been using Vim for a long time, but I'm still not very good at it. So we'll do like cam index. This database int thing, this is a global hash table of like flags that you can store like integers and booleans and stuff like that. It's just used for the argument stuff. Dash C. So if it's not, if we don't get a string after this one, yeah, the argument parser is very fragile. It breaks very, very easily, and it's not built very well, but it works for now. So we have the argument, and then we need to actually handle parsing multiple cameras. So let me just, for reference, open this guy up. So we have the camera here. I think because I have a bunch of these scene JSON files that I've made over the years. I don't want to edit all of them to have add brackets here. So I think I'll just load up the same camera, and then if it's an object, I just parse that camera, and if it's an array, we parse multiple cameras. I think we'll do that. Yeah, I think that makes sense. The JSON parsing is very flexible. I've added defaults and all sorts of stuff. I think you can even put in an empty. I've tested this at some point. You can put in an empty JSON file, and then you need to provide an asset path separately. Yeah, it works. It just loads up the default settings and everything. There's nothing to render, but it does work. And it crashes, but that's fine. It happens after writing the file. So let's see. We load up the JSON here. And I've been refactoring this lately to be a bit more flexible. Yeah, these aren't really ideal that we actually just kind of randomly get these values all over the place. I need to consolidate these. And then we override this one for the camera. And then we parse camera. What does this guy do? So we load up, yeah. We can just make this into yeah. Okay. Yeah, I think we'll factor this out to a separate function to parse the camera, and then add some logic to deal with the array. And then we update the pose for the camera. And then we recompute optics. And then this is just for testing. I added a Bezier path for the camera. You can actually do animations and fly the camera around. Did that a couple of weeks ago. Okay. I'll just make another function that I'll rename this to parse cameras. Hopefully. Then I'll do another one. So this one just returns and then okay, yes, I think that'll work. That'll copy all this stuff over there. Yeah, okay, so we'll do this one. Yeah, so like this. Cam path. We'll copy this one as well. Oh, it's used as a Vim command. Oh, yeah. We'll disable ID of Vim. I'm still kind of experimenting with that. Let's just use this like a normal ID. What happened here actually? There's a bunch of edits. I think I indented it or something. Anyway, do this one and then put this here. And then return cam. And then like that, zero initialize it. And then we need to figure out how to find and can we do Control F? I know how to do it in Vim. I don't know how to do it with. Let's see if we can do this. So we'll do select all this. Right, like this. And then I can do something like this. Okay, that works. And then update pose. This one takes a pointer, so we can just pass in the address right here. Oh. Yeah, I need to decide if I want to use IDFM or just the regular ID mode. I'll stick to the regular ID mode. Cam.path, right? That looks good. It looks happy. So this one just parses a camera. If there's no data coming in, cam data, which is return the empty camera or whatever. Okay, that works. And then here we can do stuff like, let's see, we want to turn this one and allocate them here probably. And then, let's see. So where do we actually... Cam new. We allocate it here. And it's a single camera. We're just gonna make it an array of cameras now. And actually, let's see where that is. See, yeah, I found this before. For some reason, it never finds the struct. It finds everything else, but doesn't find this one. I don't know why. You need to manually go to scene.h. And there it is. I don't know why it doesn't find this. Maybe a bug. Currently. There's a comma missing. I like how it actually checks the grammar. That's fun. So this will be renamed to cameras, which gives us the convenient benefit of it now telling us where we need to fix stuff before we can actually compile. See? Yeah, we need to fix that. Okay, so camera array, and this comment goes away. We don't need that anymore. Camera count. I'm gonna rename this to camera underscore count because I'm moving away from camel case into snake case. I have not done any changes to a lot of existing code. I'm slowly moving towards that. So new code is gonna be snake case, at least hopefully. I'm still kind of mixing, which is not good. Okay, so we have the cameras. Let's see what happens here. So here, we're gonna need to figure this out. So we're actually gonna call parse cameras here. Then we're gonna pass in cameras. Then get the CJSON, get object item. We'll still call it camera in the JSON, at least for now. I don't want to rename it in all my JSONs. I could just do like a simple set, but as I have published some scenes that I don't want to modify. Let's see here. Releases. There's some scenes that I put up here. That should hopefully still work. So we need to refactor this a bit. Our scene cameras. Right. I'm actually gonna pass in the address of this pointer. Because we want to allocate it inside the cameras thing now, I think. And that goes away. Then we figure this one out. So if CJSON is object data, now we know that it's a single camera. So how do we do this without duplication? Oh, we'll do it like this. My style is to put uses parentheses with size of, because it just looks more consistent. And then there we go. Parse camera. something like that. We'll figure that out if it's broken later. I still get confused about pointer syntax sometimes, but that's fine. We can fix it later. Otherwise, we're going to loop through. So we're gonna assert that. Let's see. All right. I don't know why it doesn't autocomplete inside this assert. I don't know why that is. Get array size. There we go. Data. Camera count. Please type correctly. Typing too fast. There we go. So we just allocate the cameras directly into that array, and they're all in like next to each other in memory, which is good. And then, well, these guys are not supposed to be here. They're supposed to be in here. And then also this one needs to be moved, I think, because we need to do it for each. Or we can do it inside here. Actually, we need to do it in parse JSON because we need to reapply the dimensions. I'll explain that later. So right now we need to JSON array for each. Takes an element. No. And then camera data. This is a little macro that iterates all over all the elements in a CJSON array. And we'll have and also we need to have an out parameter for the camera count so we can report that, like get that back out. Count. That needs to be a pointer. Something like this. Current camera. So if we have two cameras, it goes from 0 and then to 1. We need a +1 here, don't we? So cam 1. I think we need a +1. Again, if that's a bug, we'll fix that later. And then we are going to do something like current camera. Actually, we should do like this. And then parse camera. And this one takes the camera like this. Looks okay-ish. And then this one we need to move here. I think I'm happy with that. Parse the cameras, parse scene. I think we're gonna need to pass in cameras count. And then we are gonna need to do something like this. I dot height. Okay, And then we're gonna recompute the optics here. Still getting used to the way the keys are laid out for brackets and squared. Like all these brackets are like weird on Linux, different from macOS. Still getting used to them. They're actually the way they're labeled on the keyboard, whereas in macOS they're not. But yeah. So we need to recompute the optics after setting the width and height from elsewhere, from the preferences. Because the recompute optics just does a bunch of math to figure out the aspect ratio of the camera sensor, the sensor size, and evidently like other things. Yeah, it just needs the width and height of the actual final image to get the aspect ratio, which is then uses to get the sensor size. So we need to apply that. Probably a bit awkward to have to do it like this, but that'll work. And then we need to fix everything that's broken, which is can destroy. By the way, for the camera constructor, I don't think we need this one anymore. Yeah, we're just manually allocating anyway. Yeah, here we go. Oh, this is the wrong file. Let's see, camera, that one. We have a little test file that's kind of in the directory here. I made this little test file to find a potential compiler bug. Haven't tracked it down yet, but evidently Sea Lion is interested in it because it sometimes jumps me there when I search for something. Right, cam recompute optics. Let's see, make. Okay, cam destroy. See, not see. Yeah. So we have our scene here, which has the cameras array. We don't need to do can destroy, we can just free this array. Yeah, because we allocate it once, so free cameras. There we go. A lot of this manual memory allocation will be migrated to the like the blocked allocator that we have for the memory pools, but right now a lot of it's still manual, which results in some bugs like you saw the double free there earlier. Okay, what else? Now it builds further. Okay, of course. Now it's actually accessing the camera. So when we start a render, let me show you how this works. Main.c. We load up the scene and all the settings and do all the preparation we need. Then we start the render, which uses the this one will sync with the clients if it needs to, and then we actually render a frame. And then there's a bunch of more setup to figure out some settings. So it prints out a bunch of stuff, and then it prepares for the main thread. This is actually where the main thread loop happens. Right here, this is the main loop on the main thread that updates the render progress and stuff like that. It's some very ugly code that tries to give you like estimates how long it takes. But here we construct, I can actually make this full screen, can I? We construct render threads. These are local render threads that actually render on this machine, and then we have, for each network client, we have the special network render thread, which actually just handles communication with that particular client. So for the render thread state, I think we could just get the camera index inside each thread, but then we call getInt multiple times in there, and it's kind of ugly. So I'm just gonna get the selected camera index in here and do it that way, I think. Then we also need to pass that on to the network worker nodes. How would we do that? I think we do something like this. So yeah, here we load up the scene locally, and then once we're done, we actually build a cache, which is we basically just, for syncing the scene and all the assets to the render clients, we just wrap it all up into a single bundle of JSON, like, you know, potentially hundreds of megabytes. We base64 encode all the binary data, and then we send that over. So here we actually check if we have local setting overrides for our local client, and those get reflected for the most part in remotely. The thread count doesn't, but we need to also do this for the camera selection, because obviously if two different clients are rendering a different viewpoint, that will get very confusing. But let's handle the first case here of just getting it locally here. Frame. This, I don't like this about CLAN. When I find a function name, it often pops up the header first, and then I just jump here, and that's not where I want to be. I always want it to jump me to the implementation. I'm betting that there's a setting somewhere for that, but the default doesn't make sense to me. Anyway. So we start up. Let's just get default camera. So we'll just do an int. Camera. Set. And then, of course, I forgot the tag name already. I do this every time. It is called cam index, yes. If that exists, it's int ref cam index. This is how we access the global preferences thing. Otherwise, we'll just default to 0. And then we will do something like this. Let's modify our render thread state here. Camera here, and this is already shared among the rendering threads. So if we go to like a local render thread like this one, we just access the global camera here. It doesn't get modified during rendering. So here we're just gonna get, let's see, we're gonna set this one, then we make the local render threads. The local render thread that we select, but based on the mode, here we're gonna set, just gonna put like, no, this is the wrong one, this one, and equals cameras, and then we're gonna get the selected camera, like that. And then inside the thread, which we have 2 here. There's a little bit of code duplication here for now. We're gonna get the camera here. Where to state cam. And then we're just gonna place this here. Should work. We're gonna do the same thing here. And render thread interactive. Maybe this one. Here we go. Bit of duplication, that's fine for now. Okay, now it gets the camera that we selected. Will this work, I wonder? We'll still need to write the code to actually pass this on to the render clients, but I'm willing to bet it's not going to work on the first try. It doesn't need compile. Okay, compiling. Can't get Ray. Where's this? Oh, worker. We'll do a similar thing here, I think. Worker spawns up. We'll just modify this one for now. This is the actual worker thread that happens on the remote if you're doing a network render. And this one's unique. It's similar to the render thread. except that this one just does it over a network. It submits work and handles synchronously, like, the connection. So we're just gonna do a similar thing here. Thread state. Worker thread state. Okay, we'll put our camera here as well. And I feel a sneeze coming. That's fine. There we go. And this one's not set yet. We need to write some code to get this from the JSON when we're loading stuff. But it should compile now, at least. Will it work? Okay, let's just try with a single camera. I'm gonna do a debug build because I'm willing to bet it's not gonna work. Okay, it's already a debug build. Then C-Ray, input HDR. Assertion triggered, okay. Interesting. I think that's a logic error. Oh, we need to return here, don't we? So if it's an object, we just allocate that and parse that one camera and return. Okay, it just fell through. Okay. Maybe we don't count that as the first attempt. Wait, incompatible pointer types, parse cameras. These warnings are sometimes useful. Oh, it's a size T to int. Is that not a scene.h? Nope. Try that again. Sometimes it takes me to a weird place. I don't know why. Size T. That looks better. Okay, let's try that again. Didn't crash. I wouldn't say it's working. I think we might be like at the wrong spot. Yeah, we're gonna need to debug this. This is not working correctly. It's just rendering all black and very slowly, which usually means something's horribly wrong. Let's do... Make sure I haven't fucked up memory. This is the fun of working with C, as you get to shoot yourself in the foot. Okay, leak sanitizer, that's fine. We get debug build and then do like cameras. See what happens here. Okay. Step over. If we don't have any data, return. If it's an object, this should go in. Sure enough, it does. It allocates that. And then... Oops, wrong display. Wrong key. 0. And then... We don't have a cursor, but there we go. We got the camera. And if we spawn up a terminal here... look at the settings. It looks correct. Stops, yeah. These values are not computed yet. It does these later. Oh, you know what? It does the cam update pose internally. Okay, so these should be correct actually. Yeah, rod ax. These are, I think these are radians, because we can specify either degrees or radians here. They get converted to radians for the math. And position, yeah, these look correct. What is path? I don't even know what that is. Take me there, please take me there. Choose implementation, this one. What is path? Oh, it's spline, so you can do Bezier paths. that looks correct. So what is wrong here? Oh, scene loader C. And then we apply all this stuff. Cameras 0. Still looks correct. Okay. Then render frame. Let's look at the next spot. Yeah, return. We don't do anything else. Right? Then we're gonna do... we're gonna break here. Break. Render C. We'll do 77. Run this. No. How do we continue? There, C. And then we spawn up some threads, and it didn't break. It did break. Wait, what is happening? Why do I have two terminals? Whatever. Okay. Selected. Camera 0. That looks correct. I'm hitting the wrong buttons. This is very awkward. There you go. Still looks right. And then we set... maybe something weird happens here. Oh, this is not... this is actually the C-ray window. It just didn't draw correctly. What happens then? We take that one. We don't copy it, we pass the address of this guy. Which I think makes sense. We don't need to copy it, it's shared. Okay, let's break... no, let's just step. Okay, third states. And 0th. It's still correct. Oh, it's not correct. Some of it's correct. Notice that the width and height are 0. Was it like that before? Oh, I didn't even notice that. It's completely screwed up. This is supposed to have the resolution. So of course, if we don't have that, then the camera is just gonna shoot. When we get rays from the camera, it's gonna be incorrect. We'll just put it that way. Let's figure out what that is. I just missed those values. We make a camera. Then we update the pose inside. Right? And then we make that one. Oh, we don't update the cam count. Cam count equals 1. And then yeah, okay. Let's figure this out. So let's break here. Scene. I'm making heavy use of the debugger because I like it. Yeah, 1 2 1 2. Right. There's one camera. And then we have the width and height. Now we should have the sensor size used to be 0. Where's sensor? There we go. And now it's populated here. Where is it? There it is. And the aperture is updated. Yeah, now it looks correct. Maybe that fixed the bug? Maybe. Let's just run it. Maybe. Hey, there we go. That works. Cool. So we have a single camera working. Let's try and add a second camera and then switch between the two. That should work locally now. It doesn't work across different nodes, but it'll work locally. I'm not gonna render this. So let's edit our JSON here. We're going to make this. Let's first of all put this one here, like this, and then we're gonna wrap this guy up. It's gonna be an array like this. And then I forget, how do you re-indent stuff in Vim? Indent. Press that one. Huh, okay, let's see if that works. Let's try and re-indent this one. Select the block, and then what do we do? Like this? Oh, that's incorrect. That's left. Undo. Bear with me. And like this. There we go. Okay, cool. Then we're gonna add a second one, actually. Alright, I'll copy this. Like that. And then paste that after this one. And then put a comma here. What should we do? We're just gonna rotate it, make it like really obvious that it's different. I'm gonna make like a rotate Y with like 15 degrees. Let's see if this even works. So without setting anything, it should still be the same. Let's, oh. Double fear corruption. Now that's exciting. Okay. Let's run this. Backtrace. Guess file type. Okay, that's memory corruption then. Okay. Because it's unrelated. Do a quick ascend here. Won't take as long, it's fine. There we go. Cam update pose recompute composite. So heap use after free and scene loader 1214. So we use after free. Use after free? Huh. Freed by thread 0. What does this do? Recompute composite. Something's happening inside the camera. Transforms cam. Cam composite. It's composite. I don't know. Let's see. Cam update pose. Then we free that. Fine. But this one doesn't use that memory. Shouldn't touch it because, let's see. 1214, is that correct? Cameras. We haven't even touched that memory. Something went wrong. Deallocated right there. Cam update pose. We have the camera. If we update the orientation, we reset the orientation. If we update the position, we'll update that. If either are updated, then we recompute the composite, which allocates a new set of transforms Gets the position from the spline if it needs to. Then it makes a composite. Multiplies the matrices. But this one allocates and then frees here. And nothing gets deallocated that's in here. There's no pointers here. Allocated by who? 34. So this guy. And then freed on line 52. And then supposedly reused here. That doesn't make sense, does it? Doesn't touch that memory. It's not even in scope. That pointer is not in scope anymore. I disagree, Asan, but I'm probably wrong. Let me just do a once over here of the code. Reset that. How could this? Let's. Yeah. Just recompile. There's obviously some memory corruption. That is weird. Right of size 4. So how does this bit of memory, how does this get moved into where that pointer was? Something really weird is happening. You compute the optics, get the address. Parse cameras, parse that one. Usually ASAP just tells me right away like what's going on, but this is very, very confusing. That doesn't make any sense at all, does it? Checking my disk space. Oh, I'm running out of disk space. I need to speed this up. Something's going on with the dog. Okay, let's see. Parse JSON. Recompute the composite. That is very, very confusing. So it's located in 12 bytes inside a 528 byte region. That doesn't make any sense to me at all right now. I'm stumped. Completely stumped. I don't know what's going on. That's very weird. Let's look at the parse cameras once more. Allocate the camera. Correct size. Is this incorrect? Assign. What? Yeah. Maybe like that? I don't know. Yeah. No good. I don't even know if I need the parents there. I'm just gonna leave them in. 'Cause it works with a single camera. So obviously the change has to be, if we go through this path of code, it worked. We checked that. That works. So it has to be in here, right? So we assert this. We get the camera count. Should be 2. Let's... Obviously there's memory corruption, but I just don't understand where. Doesn't make any sense. Maybe that's incorrect. No, it's 2. We allocate the memory for the cameras. Cool. Makes sense. Correct size. And then we start parsing them. Parse the camera. This is a real mystery. I don't know what's going on. Let me check my disk space. Yeah, we have 76 gigs available. I don't know. Oh, I looked at the wrong number. Okay, that's good. I was looking at like 20 gigs free. That was my memory usage. So we have plenty of time. I'm betting that's a glaringly obvious bug, but I'm not seeing it right now. Usually, let me exit this and start playing. The ASAN updates. Let's do UBSAN. Do we have UBSAN? Maybe we're invoking UB. Double for your corruption out when parsing mesh. UB. And then backtrace. This is after, I think, let's see. Parse display, yeah. So we parse the camera and then we parse the scene. So this is downstream from whatever memory corruption we're doing up here. And so I don't think that this is related. This is just a crash caused by messed up memory from earlier. It's completely unrelated code. It just gets this far and then can't continue. ASAN, why would you let me down like this? I don't... Is there like a different option to get memory corruption? Yeah, ASAN. Add our sanitizer. Yeah, memory corruption bugs. Yeah, that's what I'm doing. Oops. Recompute composite. Let's go look at that function. There's something messed up going on there. There has to be. Look at this function again, and it's here. Parse the camera. So we dereference the pointer, we get the actual array, then we index into that array. Should be right? Right? And then do we have this pattern elsewhere? I'm just making sure that... Seriously, reorder tiles. We have this one here, tiles. Is that really not used in here? No, reorder tiles. Implementation, please. For middle tiles. So we use the same pattern here. And yes. Free tiles, tiles and temporary. Yeah, this is how you do it. Okay, I'm just double checking because I'm getting very confused. That's not what I typed though. Sometimes the jump to text thing doesn't work very well. At least as well as it does on Xcode. I'm gonna try and ignore this code because that works. Let's just check that it works in another scene. I have a troopers.json thing, which has a single camera, and it still crashes. How weird is that? Okay, I guess the bug was there all along. If I build this in release mode, it'll work. But only because we don't have the sanitization enabled, so this bug was there all along. So it could be this path as well. Let's get all the references here. Why is this off to the side here? Renderer. It crashes before this point. It doesn't even get here. So So the corruption-free scene cameras. We don't get to this far. Where's the cameras? Cool. Yeah, this is supposedly where the access use after free happens, which is not, as far as I know, should not be possible, because this bit of memory is definitely not that pointer, which is no longer in scope anymore. Recompute the optics. I am stumped right now. Where's the camera? What happens in here? Make a camera. If we don't have it, return it. Otherwise, we pass it to update the pose. What if we don't update the pose? Is the bug in there? So, yeah, the bug's not in there. Okay, what happens now? 1214. Allocated. Okay, now it's a heap buffer overflow. Parse camera scene loader C605. Okay, that's 605. That makes more sense. So we allocate it here. This looks correct, though. I don't see anything wrong with that. Yeah, there's no other accesses. We free it afterwards, but that's not... We're definitely allocating this correctly. It's gotta do something with my pointer arithmetic here, right? See what happens here. So we have the tiles. We can access them here. Free that tile. Temporary. Yeah. This is a pointer. We allocate that. This one returns a pointer. Yes, this all looks very sane. It looks very correct to me. Yeah, size. Struct camera. Yes, the type's correct. Confusion noises. Let's put it that way. I don't understand. So it's located 252 bytes to the right of a 528 byte region. Is this camera 528 bytes? Come on, take me there. I think it's possible. There's a bunch of floats and vectors in here. Transforms. Yeah, it's probably 528 bytes. I'm not going to check right now. Well, let's check. Break first cameras. $264 bytes. And then, 264 to, it's 528 bytes. Right? 528 byte region. So we have the two cameras. Then we're offsetting. So we're just indexing incorrectly. We're indexing to the right of where that stuff is allocated here. So it is a heap buffer overflow, but why? It's on, yeah, 1214. Something's happening down here that is not correct. We're seeing cameras. Yeah, it's an array of cameras. Do we just... index... Oh, you know what? I bet that we're running too many iterations of this. instead of 1212. Are scene camera. 3 cameras. We're parsing it incorrectly. I bet that this is the +1, isn't it? In parse cameras. So we have 2 cameras. Do we? Yeah. Camera 0. Get set that one, and then camera 1. And then we plus it. This +1 is incorrect. Okay, there we go. I knew that was... Okay. I'm gonna guess it's gonna work now. Okay, it's always... Yeah. It was incorrect. And it's very, very slow when you run it with ASAN. Do a release build quick here. That +1 cost us like 30 minutes. 20 minutes, 30 minutes, I don't even know. But there it is. It's very slow though. That doesn't look correct. The resolution's all off. What is this? Oh, this is the trooper scene. Let's do HDR. This one does not work either. Okay. So there's still something going on. But what? Let's try and fix this. Real quick here. Two cameras. Yeah, I should have read the ASAN output more carefully, because it would have been obvious if we just looked at the offsets to come up with what happened. It wasn't memory allocation. I always kind of default to that because I feel like I mess up the and then mess up the pointer arithmetic or something like that. So I was kind of just assuming that was it. There's that one. Which is not correct. The optics are correct, but the transforms are not. What happened to those? Oh, because we don't apply them. I put that comment at this line. Of course. Fixing bugs. I'm gonna guess that it's gonna work now. Almost done. Almost done. Let's just do like this one. Here we go. That works. Let's do this one. That one also works. If you're wondering what that looks like, do we have... This is like the default render that we have, like the example render we have on the GitHub README page. It's not a scene that I made. I got it off somewhere. It's like Creative Commons licensed. I just added some lights and I think it looks cool. So that works. Let's add... So we have this one. We have the two cameras here. Let's do bin, C-ray, HDR. Then we're going to do O. Camera 0.png. This is also an option I added recently, and we're not going to do that many samples. 25. You can specify where you want the file to go out, and I think I just put it wrong. Oh, there we go. Okay. Camera 0. There. Okay. And then we're going to do camera 1, and then we're going to specify -C1. Maybe it'll work. No, didn't select it. Okay. Oh, overriding output path to camera 1. Do we apply this anywhere? Yeah, we should. What happens here? Selected camera. Let's debug, please. I don't know why. Oh, yeah. This is not a terminal. This is the C-Ray window. It just seems to have a garbled memory in there. Selected camera 0. Why? Cam index. If is set. Cam index. Set database int G options cam index N. There's no warning. Dash O. Oh, why is this dash O? Stupid bugs. Why did I put dash O there? Okay. Whatever. Yes, you build, release. Now we can do our thing. Camera 1. And there we go. It's rotated along. It's doing like pitch roll. It's like doing like a yaw to the right. So open a camera. Oh, it doesn't. You can't open multiple things. That's lame. There's the first one, right? And then there's the second one. You believe me, that works. Let's sync it up to the render notes real quick. We're already running over an hour. Let's see. Load scene. So if we have the cluster thing set up, where are there spaces here? I don't know. Weird code. Let's just add this here. Then we need to add the parsing as well for that. So if is set cam index CJSON add item to object, which takes the object, which is cache. Then so we'll name it selected camera. This is only supposed to be used by like internally in the cache. You can of course write it in the input JSON, but we're just gonna sneakily passing this in. JSON get number int pref cam index, and then like that, and then parse We could just pass the camera index here, can't we? I should have thought of that. Maybe we'll just do that. Yeah, we'll do that. Like that. Let's do it here. So thread override. Yeah, we'll do this here. I think this makes sense. If is set cam prefs. Selected camera is int pref. That should do it. And then overriding. We'll just, this is not an override setting. Selecting camera eye. Like that. And then in here, select the camera. This gets called parse prefs, and then we built it. Yeah. Parse JSON. No. Load scene. Yes, take me there. We don't need to get this one from there. We can just, if it's not, if, do we even have, yeah, if our prefs selected camera isn't 0, then we can just do like this. Oops. There we go. Then we need to parse that in. We did that already. No, we need to parse that as well. So here we kind of do it twice. We need to also parse, but this is only used for the remote, so whatever. It's kind of weird. It looks weird, but it's fine. Selected camera. What do we call that? Select the camera. There we go. If selected camera. If it doesn't exist, if this number, CJSON is number. Selected camera on prefs. Selected camera value int. Like that. Okay, let's see if this will work. We're gonna spawn up a render node locally and then just run it there, I think. Make sure this still works. Yeah, this is a release build, right? Okay, so we're gonna spawn up a render node here locally, and then here we're gonna do bin C-ray HDR, and then we're gonna do samples 25. J2. So we're gonna render with 2 threads on this one and the rest on here. Notice. There we go. Now it syncs. It's a bit derpy, but that's fine. Oh, segmentation fault. Okay, why is this? Can't get Ray. It's sad because it can't get. Oh, so we forgot to fix the logic. Renderer.c. Yeah. In fact, we don't even need this one. Like that. Then in worker, Same kind of deal. Where's our changes? Where do you spawn the thing? Come on. Where is it? Cam. Receive scene. Get work. Our thread. Start render. Here we go. We set the cam. Where? Oh, we never set the cam. Okay. I think I forgot to implement this. Okay. Cameras. Do worker. I need to select the camera. I'm gonna need to wrap this a little bit, I think. Let's do something like this. There we go. Address of that. Okay, let's see if that works. Maybe. Yeah, there we go. Then we just select the other camera and see if that syncs up. Yeah, we'll fix that bug later. C1. See if that works. No, it did not sync it. So this is what it looks like. That's kind of cool, actually. So one of the nodes was rendering with the other camera, and then the one did the second camera. So it looks very weird. Kind of like modern art. Maybe I'll mint this as an NFT and sell it for $1 million. Or maybe not. Why did you not sync? Did you get the thing? Selecting camera 1. So we set our pref selected camera. Right. Then oh, yeah, I think the logic is not correct. In here, we always want to set it regardless of what it is, even in 0. Right? Should default to 0 though. Yeah, it will default to 0, so we don't need to add this if it's 0. Why did it not add it to? Let's make and then there. $169. It's gonna be nice. And then we never get here because we're not using clustering. Oh. Break. 169. Then we get here. Yes, add object to camera. Do we see it here? No, it's not here. cache. Yes. Select the camera is 1. The cache is unknown type. Whatever. Oh, because it's out of scope. Okay, whatever. Let's see here. Let's dump the JSON as we send it. Asset cache. Handle client sync. We're kind of out of scope for this one, and honestly, I could stop it here, but I want to get it working fully. Then I can wrap it up, because I need to go to bed as well. Send asset scene. Load scene data. Scene cache. Do logger. Okay, let's do it this way. Oh, come on. Why is this not working here? There we go. Oh, I forgot to add in dash. What? Where? Oh, there we go. What? Where did my JSON go? Hold on. Hold on. Hold on. Hold on. Make. Oh, we need to use printf because our formatting printout thing doesn't support strings that long. This is getting too difficult. That programming sometimes is. That's fine. Just get a printf here. Make. Okay, here we go. And then I do like previous next. No, come on, why did it? Selected camera next. Selected camera is 1. It is there. Why is it not parsing it? Okay, so selected underscore camera. And then parse prefs. Selected camera. Selected camera. The bug could be these typed wrong. If it's a number. $3.59. Okay. Return. Get object ID. Get object ID. Where's that? I don't see that. Oh. If it doesn't detect that as a number. Why is not? Why is not? CJSON number. How is that not a number? Whoa, what happened there? Not stopped at any breakpoint. Continuing. It's not a number. What is this data? Is this the... Oh, the data is the wrong object. I'm reading it. This is prefs. We need to parse it elsewhere. That's stupid. Yeah, of course. Yeah, we need to parse this in like... Parse JSON or something. So we parse the preferences in here. Let me just put this here. JSON. Why is this not happy? Not assignable. Pretty sure that's right. Make. Okay, now it should work. There we go. This terminal is fucked up, but that's fine. C1. Hey, look at that. Now it syncs it up. Okay, I think this is gonna wrap it up for tonight. We have a double free, which I'm gonna figure out after this recording. Or I'm probably gonna go to bed. But it works now. Let's see what we did. Yeah, so we refactored the camera a little bit. We sync up the... Select the camera, we parse the argument. We parse the cameras correctly. And does it still work? This one has a single camera. What happens if we select an invalid camera? Maybe it'll crash. Maybe not. Oh, there we go. It works. It just selects camera 1, but then somewhere it brings that back. Okay, I think that's it for today. If you got this far, which is 1.5 hours, yeah. Thank you very much for watching. I appreciate you. And I hope to do more of these videos now that I have my recording setup all set up and yeah, I have the coding mojo again. So, thank you for watching and good night and Merry Christmas.